Now for the structure questions for your exam, we have two types here. So that is type 1. Let's answer all these questions. A laser produces a ray of blue light of wavelength 4 times 10 to the minus 7 meter. State the speed of light in a vacuum. So in this question, all that you need to do is write the speed of the wave in the vacuum, which is the speed of light. Second question here. Calculate the frequency of the light produced by the laser. So the only option that you have is use the formula for the wave, which is the speed of the wave is the product of the wavelength times frequency. So it's looking for frequency. So let me rearrange this formula, speed over wavelength. Now, the speed is this one right here. Why? Because light travels with the speed of light. There we go. So that is 3 times 10 to the 8. And the wavelength was given at the beginning of this problem. So 4 times 10 to the minus 7. Calculator time. So here is 3EE8 divided by 4EE negative 7. Okay, so the frequency is 7.5 times 10 to 14, and the unit for frequency is hertz. Next question. The ray of blue light passes from air into a glass block. So this picture shows the ray making an angle of 35 degrees with the side of this block. The question asks, state the angle of incidence of the ray of blue light on the glass. Of incidence is the angle the ray makes with the normal. So this is the normal right here, and we are looking for this angle. So right here we know this is 90, so 90 degrees minus 35 degrees is 55 degrees. So this answer is 55 degrees. Next question. Glass has a refractive index of 1.5. Calculate the angle of refraction of the light in the glass. Snell's law time. So here is N1 sine of theta 1 is equal N2 sine of theta 2. Identify 1 and 2 here. 1 is above the boundary line and 2 is below the boundary line. So 1 here is N is the air, which is 1. Sine of the incident angle, is 55. And 2 is the index of refraction of the block, and is 1.5. And sine of theta 2. So now we are going to divide both terms by 1.5, and sine of theta 2 is, calculator time again, so 55 sine, which is this, right, divided by 1.5. So I'm just going to write a few numbers here, but I will keep everything in my calculator. So my angle is the inverse of a sine of this. So inverse of a sine is 33.1 degrees. So some students did 33 degrees, which is fine. So that is the answer for this. A figure 6.1 shows a ray of light incident on the surface of the glass block. So that's the glass block. And on this picture, accurately draw the reflected ray. The best way to do this, normal line time, right here. And the reflected should have about the same opening here. So that will be the answer. Reflected. So this angle and this angle are the same. B, This picture here shows a ray of light incident on a glass prism. So put one tick only in each line of the table to indicate which of the angles labeled in this picture are the angle of incidence and the angle of refraction. So a couple of things here. Is asking to identify just the angle of incidence and the angle of refraction from this picture. So let's take a look and let's flip. So I want this facing me, the normal line. So I know the incident angle, incident ray is this one right here, and this is the incident angle that makes with the normal. So this is V. So V here is my incident angle. Now the refracted angle is the angle that, this is the normal, the angle that makes with the normal, which is Y. So this is my refracted angle. So the incident angle letter is V, and the refracted angle letter is Y. Now, this question says this. The refractive index of water is 1.33. No news here, right? We did this in the lab. A ray of light passes from water into air. The angle of incidence at the water-air interface is 30 degrees. Calculate the angle of refraction. Snell's law. N1 sine theta 1 is equal N2 sine of theta 2. Now, who is 1 and who is 2? Is from air, water to air. So this is my 1 and this is my 2. So N1 is the index of refraction of water. So it's 1.33 sine of the, do we have an incidence angle? Yes, 30 degrees. And 2 is the air, which is 1. And sine of the angle right here. So that's what we are looking for, the refracted angle for this case. So sine of theta 2 is equal, calculator time, and here we have 30 sine times 1.33, 0.665. So my angle is the inverse of a sine of this value, which is 41.68 degrees. Okay, so if you guys want to write 42 degrees is fine, or this number is fine. I did not deduct any point for this. Next question. A ray of monochromatic light passes through the glass prism shown in this picture. State what it meant by the term monochromatic. So I can split this word into two parts. Mono means one, and chromatic or chrome means color. So the answer is a light with a single color or one color. So both ways are correct. Is a single color light or a light with one color. State the name given to what happened to the ray at A. This is A. What happened here? The light refracts. So what happened here is a refraction. Refraction. This is what happened. Next, use the values on the diagram to calculate the angle of refraction at A. The angles in a triangle adds up to 180 degrees. So it's asking what is this angle right here. So in this corner, we have 90 degrees. So it will be 180 minus 90 minus 61 is 29 degrees. So this angle right here is 29 degrees. So when we add all three, is equal to 100. So 180 minus 90 minus 61 is 29. Calculate the refracted index of the glass. Snell's law time. So this is N1, sine of theta 1 is equal to N2, sine of theta 2. If you are lost where we are at point A on that diagram right here. This is where we are. So we want to calculate here the index of refraction of this glass here, this prism, right? So remember, this is 1 and this is 2. So then your 1 here is the air. So it's 1 sine of the angle of incidence, which is 45. And 2 is, that's why we want to calculate, right? So N2 and sine of the refracted angle at point A, which is 29 degrees. So 45 sine divided by 29 sine equal 1.46. It's fine. 1.46. That's the index of refraction of the particular glass. So explain why the ray does not emerge into the air at B, but does emerge at C. So at B, there is a total internal reflection. So that's why does not emerge from B. Okay, so at B, there is a total internal reflection and can be verified by the error that it will be displayed during calculation. At C, the incident angle would produce an angle of refraction, just like the problems that we did in classroom. So this angle right here, the incident angle of 46 degrees, will produce an error. But at C location, so this incident angle will produce a refracted angle. So that way the light can exit the prism at the location C. So this is all for these type of structure questions.